Hi, so we're going to have a look at modeling from point cloud data. We're going to have a look at Autodesk Recap and Autodesk Revit together in a coordinated workflow. The Recap software is an absolutely brilliant piece of software that Autodesk brought into their product range a couple of years ago, which was brought in from Alice Labs originally. It's got this really nice Windows 8 looking interface which allows us to very quickly and easily navigate around our point clouds. Now Recap is brilliant at actually federating or combining or merging or registering our clouds together, and you can do that from a number of raw point cloud file formats such as FLS, Leica, PTX files and PTS files, Zoller files and E57 files as well, and it very quickly and slickly brings them all together. It's making the information incredibly accessible for users. I can really quickly navigate around the model, as you can see by my demonstration here, and it gives us a really good impression. One of the nice things about it is you move around the model, it actually removes points, so to make the work easier, not to work your processor too hard. Indeed, this has been run on a standard laptop. I can do quick dimensioning tools. As you can see, get some reasonable accuracy in those dimensions to do interrogation, and those dimensioning tools are improving all the time. For example, recently they've added axis locks and better surface recognition into the software as well. So it's continuing to develop as you would expect from a new piece of software. We can visualize the cloud in a number of different ways, so we can look at intensity and elevation. We can change the banding, color banding on there as we want, and we can also show the colors by where the scan was located. We can change the point sizes, which is very effective as well, and we can use these limit boxes. Now these limit boxes are great for chopping into the model. They're a little bit like section boxes in Revit, and they allow us to chop in and look within the building. And I'm just going to run this through a little bit just to isolate a particular room within the building, and you can see it's pretty easy to achieve. So here's the room that I want to work on. I'm just going to clean it up a little bit, and then I'll save this limit box as something that I can go back to later on. The other thing that we can do in here, which is not shown in this video, is we can actually go and add regions as well, which are a little bit like layers that you'd see in AutoCAD and things like that, maybe categories within Revit. So we can actually go in and choose walls and so forth and put them into the limit box, to put them into the region so that we can turn them on and off visually as well. One of the really nice parts of the Recap software is our ability to do cropping boxes or crops around the particular area selections, and just use the delete option to remove erroneous noise, erroneous points from our model. So that, for example, this radiator that's in the corner here, if I'm using this model to create a Revit model, what I want is to be able to see the walls easily, and this radiator might give me invalid snap points and so forth. What we would then do after this is we can export this using Recap into what we call a unified RCS file, which is Autodesk's proprietary format for clouds, which Autodesk software like Revit can read in. So I want to show you this in a coordinated way. I want to make sure that you can use these point clouds in relationship to your overall site. So we're going to use that GIS map that we created in the earlier video, and we're going to bring that in within meters. This cloud was actually captured in the grid that we use the GIS data for. And you can see that as I bring the map in, that survey point that was discussed in the earlier video is in the center of the map. What we'll do is obviously acquire the coordinates from the CAD file, and remembering that what we don't do is we don't move the CAD file. The CAD file stays in the center of the model. Nothing can be geometrically more than 20 miles away from the center of the Revit file, but the survey point, because that's not geometric, is able to be over 20 miles away from the center of the file. So the principle is move the coordinate system, not the model. And you can see now that if I look at my coordinate system, it's correct. It's just by moving the relative position. The model itself hasn't moved in any way. So I'm going to come into my area where my building location is, and I'm just going to go to Insert. I'm going to bring in my point cloud data, and I'm going to find that unified RCP file that I created. And one of the things I need to do is, because it shares a common coordinate system that was captured on site, I'm going to use the open here, and we'll see that it falls into the correct position on the site. So next up, I want to talk about how we actually produce a model, a building information model, something that is you can interrogate, get materials from quantities and so forth. First of all, we need to set up our datums. A really key part of modeling is actually getting your datums into place, making sure that they're coordinated with the overall site. So I've sped up this video a little bit, as you can see. So I put those level datums in, and I might go and have a look at cropping the particular view as well, just to make sure that I'm not seeing point data which is more than what we actually need. This view range tool allows me to crop the vertical element of the building as well, so I can go ahead and bring the bottom of the crop up so that I can lose the floor, which makes a slightly cleaner model for me to be able to see the walls and so forth. So now I'm not seeing the first 100 millimeters away from the datum. I can start looking at building wall systems, and I'll build a wall in here. Again, if you haven't seen Revit before, I can build this up as complicatedly as I want to. So I can put insulation in here and those sorts of things. One of the things that I might want to do is use a manufacturer specific material that you can get off an online service like BIM Store or MBS Library. Here's one that we've been working on. We've been working with some colleagues at Wienerberger, and you can see here that in that material we have full thermal physical data, Kirby parameters, tolerances, MBS references, uniclass codes, actual properties to do with it, such as water absorption rates and all those sorts of things. So that content is freely available to you, and you can make use of it where you know these materials exist. One of the things you need to do when you're actually building walls and so forth is make sure snap to point cloud is switched on, which is keyboard shortcut PS in here, PC, beg your pardon, and I can very quickly snap it in, and it actually snaps onto it. Sometimes it's a soft snap, but it does actually go and snap in and give you the accuracy that you need. It's also worth mentioning at this point that there is no auto recognition at this point within the Revit software, but that sort of software is available to you by external providers such as the Edgewise software, which Excitech do currently support and can sell and train if you need it, and that will actually go and draw your walls, pipe, duct and structure in there automatically for you as automatic recognition, and create it into Revit elements for you directly. If you're interested in that, just give us a quick call. So you'll see here that I can very quickly within the Revit software, again I might just go and isolate this window position. I'm just doing this with simple model lines. It's quite a nice technique to sort of map out particular locations, because that gives me snap points which I can use to snap in conceptual window openings and things like that. And very, very quickly and easily you can start to produce your building data. So one of the challenges of this particular model was that it's got a curtain wall facade. We've actually gone and modelled that, but there is a particular piece of bracing across here. So where you lack auto recognition software like Edgewise, you can use sections and so forth, and my advice would be to draw things like model lines to give you sort of the diameter of a particular piece of bracing, and you can actually go and bring that in. You can interrogate it and understand where it is, and then bring in the structural framing families and find your appropriate CHS circular hollow section frame element. Choose the appropriate size, which is as close to what you've just interrogated as possible, and then using just reference planes you can quite quickly snap that into place. You can see in my section there that it's in, and you can see our eventual model. So at this point, Scan to BIM Services is fairly manual. We've got training courses and so forth to help you understand this a bit further, but hopefully that was a useful introduction to modelling from cloud within the Autodesk platforms within a coordinated real-world environment.